Okay, let's dive right into this explainer and figure out why shouting at our toddlers isn't just completely exhausting, but actually neurologically ineffective. Welcome to the explainer. Today, we're unpacking a really groundbreaking 2024 study out of the University of Oxford. It completely changes how we look at toddler impulsivity, and honestly, it reveals why your little one might be working way harder than you think just to stay perfectly still.
Look, we've all been there, right? You face that deeply frustrating moment when a toddler reaches for something they know is absolutely off limits. They stare right at you while you firmly say no, and then they do it anyway. It feels so deliberate. You naturally assume, okay, they're testing my boundaries, or they're just being defiant. But science actually shows this isn't intentional defiance at all. It's not a lack of respect. It's actually a symptom of a massive, invisible construction zone happening right inside their growing brains.
Now, for years, researchers were stuck in what they called the toddler data desert. I mean, just think about the logistics for a second. Trying to get a 1-year-old to sit perfectly still in a massive, super noisy MRI brain scanner, all while expecting them to follow complex instructions? Yeah, practically impossible. Because of this, that second year of life remained pretty much a total mystery. But that 2024 University of Oxford study, led by Abigail Fisk, finally found an incredibly innovative way to look beneath the surface. To cross this data desert, the research team brought in a fascinating piece of tech called FNIRS, or Functional Near-Infrared Spectroscopy. I know, it sounds super complex, but it essentially just uses light to measure oxygen levels in the brain in real time. This is huge because it allowed scientists to track exactly which parts of a toddler's brain were working the hardest. And the best part, the kids were awake, moving around, and just naturally interacting with a task. So this new tech let them introduce something called the Early Childhood Inhibitory Touchscreen Task, or ECIT. It's basically a specific challenge designed to test those impulsive urges. Here's how it works. First, the toddlers are taught to touch a friendly smiley face on a screen to get a fun animation. Once they build that habit, bam, the smiley face suddenly moves to the opposite side of the screen. The true test here is whether the child can stop their automatic, ingrained urge to touch the old spot. Okay, here's where things get truly fascinating. This test revealed a massive behavioral paradox. Between 10 and 16 months, the toddlers didn't actually get any better at stopping themselves. They failed the touchscreen task just as often at 16 months. But, and this is a big but, their brain scans told a completely different story. The 16-month-old brain is actually working significantly harder. It shifts from using just a tiny area on the right side to this widespread bilateral recruitment. It pulls in the left side and a specific region called the right inferior frontal gyrus. That is literally the exact same area adults use for mature self-control. They are pulling in far more resources, yet still failing the task. So what does this all mean? The crucial takeaway is that these toddlers are right in the middle of a massive, invisible reorganization. Researchers call this the neural gap. Functional brain maturation is happening way, way before any actual behavioral improvement shows up. To put it in tech terms, it's like your child is actively building the hardware for self-control, but the software, it just isn't ready to run yet. The neural circuits are forming, for sure, but they just cannot reliably execute the command to stop. And this brilliantly illustrates why shouting no fails so spectacularly. When you raise your voice at a toddler caught in this neural gap, you are literally yelling at a brain that has absolutely zero energy left to process your loud command. They are not choosing to ignore you. Their prefrontal cortex is already maxed out on resources, just trying to coordinate this internal reorganization. It simply cannot exert control over their physical actions while simultaneously processing a high-stress auditory signal from you. So, instead of reacting with pure frustration, we can use these findings to pivot. Let's look at Section 1, the Informed Ally Approach. We're going to cover 4 science-backed shifts to support the neural gap. The very first shift is called the whisper buffer, because the study shows that the 16-month-old brain is already recruiting widespread regions and working overtime. Adding a loud, high-stress verbal command like a shouted no can actually induce sensory overload. So what do? By simply lowering your voice to a whisper and moving physically closer, you reduce that sensory noise. This allows those newly recruited brain regions to focus purely on the physical task of stopping the impulse, instead of trying to decode your volume. Second, we have the replacement anchor. The researchers noted that simply telling a developing brain, "don't touch," demands pure inhibition, which is arguably the hardest thing for a developing prefrontal cortex to pull off. But giving them an alternative target, that completely changes the game. If they're reaching for your phone, don't just say no.
Give them a yes to anchor to. Say something like, touch the blue ball instead. This brilliant little pivot shifts their brain from a nearly impossible pure inhibition task right into a highly manageable redirection task. The third shift is mirror narration. Remember that data desert we talked about? Your toddler's intense internal struggle isn't visible to the outside world, but you can actually help bridge that gap. You do this by calmly narrating their struggle out loud. You might say something like, "Wow, I see you really want to touch that. It's so hard to stop your hands." By doing this, you're validating their experience. You essentially act as their external prefrontal cortex, helping them properly label the impulse that their brain is currently working so fiercely to manage on the inside. Finally, we have the anticipatory shield. This one requires us to manage their physical environment to protect their developing brains. Since we now know definitively that brain maturation happens before behavior actually improves, a 16-month-old literally cannot be kept safe through verbal rules alone. Our job isn't to train them through shouting. It's to manage the room so they don't exhaust their limited neural energy on constant inhibition. If they can't stop touching the glass vase, just move the vase. You're protecting them from the exhaustion of constant failure.
Now, if trying to implement all of this feels like a mountain of pressure, seriously, take a deep breath. You do not have to get it right every hour of every day. In fact, child development research shows that being responsive and attuned just 50% of the time is more than enough for healthy growth. Consistency in these small shifts beats absolute perfection every single time.
Practicing this kind of tactical empathy means remembering that your child is not being naughty or manipulative when they break a rule they literally just repeated back to you. The 2024 brain imaging is wonderfully clear on this. They are incredibly brave. They are attempting to recruit more and more neural territory to become the person you are teaching them to be. They are doing the grueling, totally invisible hard work of building a prefrontal cortex entirely from scratch. When you stop shouting and start supporting the neural gap, you aren't just managing a daily tantrum. You are actively building a resilient, self-regulated thinker. This early inhibitory control actually predicts their academic skills and future well-being. By changing how you view their impulsivity, you become a partner in the most important construction project on Earth. So, knowing what is truly happening inside their busy little minds, how will you handle the next stare down?